All right, so I'm going to talk about interference of two pulses. So first, I just want to show you what a pulse is. This is a pulse. This one is reflecting back and forth. But on this program, what you can do is there's actually a second pulse. I had it down to 0. So if this is in the middle, it's a height of 0, but you can actually have a positive pulse and you can go down to a negative pulse. Let me just leave that one at 0 so I can show you a negative pulse. Okay, negative pulse just means that the amplitude is below the rest position. So you can run that. But what is so cool, and I'm excited about this program, because I can't be in class showing you this, is that I want to show you what happens when these two pulses interact on the same medium at the same time. So I'm going to do two pulses. Let's do at maximum height, just because that's maybe the easiest thing to do. So make sure they're both at 3. And so what I want to show you, maybe I can reset it. Okay, so we'll do them both at 3. All right, and I'm going to run this, and I can actually slow down the animation speed. But what happens right here, as I'm going to pause it and show you and explain, just maybe right before they go over top of each other. So what happens is the two pulses, one traveling from the left and one traveling from the right, are interacting on the medium at the same time. So you can see the amplitude here is 3 squares. And I could just run it for a moment. They're right on top of each other. And you can see the amplitude of the medium is this dark line. And it is at an amplitude of 6, because what's happening right there is the energy from both of the waves is adding up. Okay, we can see the energy as the amplitude. So one is 3 and the other one is 3, so they add up to 6. Now I don't know if I can change this in the middle. Oh, I can. That's so cool. So if I change this to a height of 2, okay, we can see them both at the same time. So that this must be the orange one here, because it has an amplitude of 2. And this one has an amplitude of 3. So we add up 2 plus 3 is 5. 1, 2, 3, 4, 5. So this would be considered constructive interference, because the amplitude of the resulting wave is greater than the two traveling pulses. Okay, this is the resulting wave from two separate pulses, and we can let that run. And I'll speed up the animation. And what I want to show you is that these two pulses don't really affect each other. They travel through each other. It's just that their energy adds up momentarily. Okay, and we could just keep watching this all day long. Wouldn't that be fun? But what happens when one pulse is has a negative amplitude? So I'll go to -1, and I don't know if you can guess what happens. Because, oops, let's slow that down so I can go back. Well, maybe we'll speed up and then I can run. And on the way back, I'm going to slow down the animation. And right when they're, oof, I missed it a little bit there. Okay. I wish I could go back a little bit. Okay. But what you can see is this has an amplitude of 3, and this one has an amplitude of 1, and this has roughly an amplitude of 2. So this is considered destructive interference, because the amplitude on the medium is less than one of the waves, or less than, so this one it was 3, so it's 2, it's less than. So cool. Now what happens if they are equal in height, okay, but opposite? And I'll let that run. And we're going to see what happens when they interact at the same time. I will pause this. Oops, I missed it. Okay. I don't know if you can see that. I wish I could drag these pulses separately. Can I drag them? Nope, can't drag them. Okay, but for a moment, okay, I'll let this go, and then I'll try and pause it down in a second. Okay, ooh, let's run that a little bit more. Okay, and as we can see right now, the two waves are interacting and the amplitude is decreasing. And here we go in the moment, boom, total destructive interference. So cool, okay? So that's what our note is going to be about today. Okay, now apparently my recording